This video is looking at the inverse tangent function. And before we look at the inverse function, just like before with the inverse cosine and inverse sine function, we want to look at the tangent function. So if we go to the calculator, we're going to graph our tangent of x. And recall when we look at the graph, this is where we ended up with several vertical asymptotes as the graph is going up here. And we can certainly tell, just like with the other graphs before, the tangent function is not a one-to-one function. So if this is our y equals tangent of x, clearly this does not pass the horizontal line test, so therefore it's not one-to-one, which again means it is not, or it does not have an inverse. Well, that means just like before, we have to restrict the domain. So if we restrict the domain, we can make it a one-to-one function. And we want to focus on this part of the graph that goes right through the origin. And if we were to restrict the domain here, this would be from negative pi over 2 to a positive pi over 2. And that's going to be our domain. Now realize at this point we have vertical asymptotes. So this is going to be a little bit different from the cosine and the sine function because for the tangent, notice here, there's actually vertical asymptotes at pi over 2 and negative pi over 2. So for the domain, we're not going to use brackets because they're not included. We have to use parentheses for negative pi over 2 to a positive pi over 2. And the reason, again, we're using the parentheses is because negative pi over 2 and pi over 2 cannot be plugged in for the tangent, because if you recall, that's where we're going to get division by 0, which makes it undefined. So even though we're going to restrict the domain from negative pi over 2 to a positive pi over 2, we'll notice that that really has no effect on the range, because we can still get out negative infinity to positive infinity, which would be all real numbers, because this graph is going to continue to go up and down forever, so we would get out all possible y values. So now that we have restricted the domain and range, now we know that the tangent function is only looking at this part, so we will have the inverse. And if we were looking at the inverse, we can graph the inverse function. Y equals the inverse tangent of x. And we'll go back to the calculator for that. So y equals, we would then hit our second function in tangent. So we get this inverse function. And we go to graph. And notice now our curves changed. And if you think about this, remember what happens. We're switching the domain and range. So that means we're switching our x and y values. So whereas up here above, we had domain as negative pi over 2 to positive pi over 2, and the range is all real numbers. Notice now the domain is the range from above, so that means this is going to be all real numbers. Okay, and that's again because we can see that the graph here is going to go to the left forever, and it's going to continue to go to the right forever. But now we have horizontal asymptotes here, and therefore the range is only going to be from negative pi over 2 to a positive pi over 2. So that means when you're using this inverse tangent to find the angle is going to be somewhere between negative pi over 2 and a positive pi over 2. And once again, we'll never get out negative pi over 2 or positive pi over 2 because that's not part of the range, because that's not in the domain up here for our tangent function. So what that means is, kind of as a visual, I kind of like to think of this in terms of, again, our unit circle. The only angle that we can get out when we use the inverse tangent would be a negative pi over 2, okay, and I'm going to put an open circle because that's not included, all the way up to a positive pi over 2, So this is the range of angles that we can get out, anywhere from a negative pi over 2 to a positive pi over 2. And again, the open circle simply means pi over 2 is not included. So if we look at an example, that means if we were trying to find the inverse tangent of, let's say, 1, what is that going to be equal to? Well, the inverse tangent of, I'm sorry, let's make it not 1, but let's make it a negative 1 here. Well, that means we're looking at what angle do we have y divided by x? So where is y divided by x? Because our tangent is y over x. So where does that equal 1? Or I'm sorry, where does it equal negative 1? So where is our y coordinate divided by the x coordinate equal to a negative 1? Well, we know that we have to only look in the positive first or positive second, or I'm sorry, in the positive angle in the first quadrant or a negative angle in the fourth quadrant. And the only place that we're going to get a negative 1, we're going to find that right through here, this coordinate where we would have x is square root of 2 over 2 and our y coordinate is a negative square root of 2 over 2. That's where we have the same x and y value, so when we divide it's going to be 1, and one of them's negative, so therefore we're going to get the negative 1. And this angle turns out to be down here. Now if you look on your unit circle, you would say, well, the angle is 7 pi over 4, but remember the range that we're talking about up here, this angle must be a negative pi over 4. So therefore the inverse tangent of a negative 1 is equal to a negative pi over 4. Now of course if you were to enter this, this would be your answer, but we also know that 7 pi over 4 would actually put us in the exact same location. But when we're thinking of using this inverse tangent, for example, to fit within our range, we're going to get out this answer of a negative pi over 4. So hopefully now you're starting to realize and become a little bit more familiar with these inverse functions. And just as a reminder again, when you use this inverse function, so anytime you're going to the calculator and you start using second tangent or second cosine or second sine, the inverse functions here, they are used when you're looking for the angle. Okay, so that's why when you look at this inverse tangent function here, when we plug something in, what we get, the output here is going to be an angle. So we're looking for the angle that gives us that particular value.